Hello everyone. Today we are going to start the next part of electricity chapter, that is the part 2. In the previous chapter we have already learned about the definition of electricity, electric current, electric potential, potential difference and current and voltage measurement. Today we learn about the ammeter, voltmeter and their function, Ohm's law, factors affecting resistance, parallel and series combination of resistors. Please watch my full video, then subscribe and press the bell icon to get updates. Let's start. Ammeter. What is ammeter? Ammeter is a device used to measure current flow through a circuit. So, how much current is flowing in a circuit we can measure by using ammeter. You have to keep in your mind, ammeter always be connected in a series. Positive side of ammeter must be connected nearest to the positive terminal of the battery and vice versa. You have to also keep in your mind, ammeter should have low resistance value. Next is voltmeter. What is a voltmeter? Voltmeter is a device used to measure the potential difference in a circuit. Voltmeter must be connected in parallel to the circuit and the positive side of the voltmeter is connected to the positive terminal of the cell and vice versa. Next is Ohm's law. Before going to discuss about the Ohm's law, you have to know about ohms. George Simon Ohms was the German physicist and mathematician. As a school teacher, Ohms began his research with the new electrochemical cell invented by Italian scientist Alessandro Volta. Using the equipment of his own creation, Ohm found that there is a directly proportionality between electric potential difference applied across a conductor and the resultant electric current. This relationship is known as Ohm's law. So, according to the Ohm's law, at constant temperature, current flowing through a conductor is directly proportional to the potential difference across its end. Mathematically, V proportional to I and V by I equals to constant, where the constant term is R. R is known as resistance and the unit of resistance is denoted by the name of ohms is ohm. Now if we'll draw a graph with V versus I, that is the potential difference and electric current, then we'll get a straight line passing through the origin with positive slope as shown in the diagram. Now, when an electron traveling through the wires and loads of the external circuit encounters resistance. So, the resistance is the hindrance to flow the charge. For an electron, the journey from terminal to terminal is not a direct route, rather it is a zigzag path that results from countless collisions with fixed atoms within the conducting material. The electrons encounter resistance, a hindrance of their movement. There are two different kinds of resistors, fixed resistors and variable resistors. Fixed resistors have only one resistance value. But variable resistors can be adjusted to change the resistance in a circuit. For an example, rheostat. Now, what are the factors affecting resistance? First factor is the length of conductor. Resistance is directly proportional to the length of conductor. Secondly, cross-sectional area of conductor. Resistance is inversely proportional to the cross-sectional area of a conductor. Resistance also depends on nature of the material of conductor and temperature of conductor. With the increase of temperature, resistance increases. So therefore, mathematically, we can state that R proportional to L by A, and hence R equals to rho L by A, where rho is the proportionality constant, which is called resistivity or specific resistance. Resistivity can be defined as the resistance of a conductor having unit length and unit cross-sectional area, and hence its unit is ohm meter. You have to keep in your mind that metals and alloys have very low resistivity, whereas insulator have very high resistivity. As a result, the resistance are also more. Now, there are two ways of joining resistors together. One is series connection and another one is parallel connection. In series combination of resistors, when two resistors are connected end to end consecutively, they are said to be connected in series. And according to the law of combination of resistance in a series, we can tell that the equivalent resistance is the sum of individual resistances. Now, how to derive the equivalent resistance in series circuit? In series circuit, the current I is same in all part of the circuit, and the sum of voltage, that is V1, V2 and V3, is equal to the total applied voltage V. That is V equals to V1 plus V2 plus V3. From Ohm's law, we know that V1 equals to IR1, V2 equals to IR2, V3 is equals to IR3 and V equals to IR. Since V equals to V1 plus V2 plus V3, then we can write it down IR equals to IR1 plus IR2 plus IR3. Dividing all of them with I, it gives R equivalent in series combination equals to R1 plus R2 plus R3. Thus, for a series circuit, the total resistance is obtained by adding together the values of the separate resistances. Resistors in parallel. When two or more resistors are connected between the same point, they are said to be connected in parallel. And according to the law of combination of resistance in parallel, the reciprocal of the combined resistance of any number of resistances connected in parallel is equal to the sum of the reciprocals of the individual resistances. That is 1 by R is equals to 1 by R1 plus 1 by R2 plus 1 by R3 and so on. Now derivation of equivalent resistance in parallel circuit. In parallel circuit, the sum of the current I1, I2 and I3 is equal to the total circuit current, that is I. I is equals to I1 plus I2 plus I3. In parallel circuit, the source potential difference is same across each of the resistor. So from Ohm's law, I1 is equals to V by R1, I2 is equals to V by R2, I3 equals to V by R3. Since I equals to I1 plus I2 plus I3, therefore we can write it down V by R equals to V by R1 plus V by R2 plus V by R3. Dividing all of them by V, we can write it down 1 by R is equals to 1 by R1 plus 1 by R2 plus 1 by R3. Thus, the reciprocal of the equivalent resistance of a group of resistances joined in parallel is equal to the sum of the reciprocals of the individual resistances. Now solve the numerical. For the circuit shown in the given figure, determine the reading on the ammeter and the value of resistors R2. Thank you everyone. Have a nice day.